بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 2.2 and it's about quadratic functions or parabolas. Uh, Let us start by this application preview. Well, additional equipment, raw materials, labor may cause variable costs of some products to increase dramatically as more units are produced. So total cost functions are not always linear. We studied uh, cost functions, linear cost functions before in the previous chapter. Now we will talk about cost functions, total cost functions with quadratic equation. So suppose that this is a total cost function of producing a product. It's a quadratic equation where x, as usual, the number of units produced. Uh, so the cost would be a quadratic function. Now, if we want to find, for example, the cost of producing 10 units, we just replace x by 10 and find the cost. The revenue, as usual, we found it by multiplying the number of units times the selling price. So the revenue here would be linear. Uh, we remember that the profit is the revenue minus the cost. Notice that the cost is quadratic, revenue is linear. If you subtract revenue minus cost, you will get a second degree or a quadratic function. So the profit would be also a quadratic function. Now we can use this function quadratic to find how many units give maximum profit and what is the maximum profit. Okay, we will see that in example 2. So we will learn also here how to find the maximum point or minimum point for a quadratic function. Well, we studied this function, the linear function, first degree function in chapter 1. And now we will study quadratic or second degree functions. This is the form of the second degree function. A, B, C are numbers, real numbers, and A shouldn't be 0. Otherwise, we will go back to a linear function. Well, what is the graph of such a function? The graph of a quadratic function is always a parabola. We can see here in the following figure the graph of y equals x squared. This is the graph of y equals x squared. It's called a parabola. This is the vertex of the parabola, and in this case, it is the minimum point. And this is the axis of symmetry. The vertical line x equals 0 in this case is the axis of symmetry, and the point 0, 0 is the minimum point, and it is the vertex. This is the parabola y equals x squared. Uh, what about the parabola negative half x squared? Well, negative x squared, y is multiplied by negative, so we will have a reflection about the x-axis. So this would be the graph of the parabola y equals negative half x squared. And half type of shrinking, So we will have vertical shrinking. If you vertically shrink the parabola, it will be wider like this. Here, the vertex, which is again 0, 0, is the maximum point, and the line x equals to 0 is the axis of symmetry of the parabola. Now, let us talk about the vertex of the parabola. Well, the parabola opens upwards if a is positive. As we have seen, x squared here, it opens upwards. While if a is negative, the parabola opens downwards. So here negative half a is negative half, so the parabola opens up downwards. Well, the vertex, if a opens upwards, the vertex is the minimum point. If if a is less than 0 and the parabola opens downwards, the vertex is the maximum point. So the vertex is the minimum point if a is positive. The vertex is the maximum point if a is negative because it opens downward. Here it opens upward. The vertical line through the vertex is called the axis of symmetry uh, because half of the graph is a reflection of the other half through this line. So if you reflect this part, it will be the other part. So this is the meaning of axis of symmetry. If we talk about this parabola, this means we started from this parabola and we moved 2 units to the right and 1 unit down. So the vertex, instead of being 0, 0, it would be 2 and negative 1. 2 units to the right and 1 unit down. And also the axis of symmetry will be shifted. So instead of x equals 0, it would be x equals 2. What about the graph of this parabola? Well, it is similar to the graph of this one, which we have seen opens downwards, but 1 unit to the left and 2 units up. So the new vertex would be negative 1 because we moved 1 unit to the left and 2 units up. So the new vertex would be negative 1 and 2. So here you can see the graph of this parabola. The vertex is 2 and negative 1. Notice negative 1 is taken as it is, but here we have negative 2 and we write it 2 because 2 units to the right. So we will move 2 units to the right, so x will be 2. Also here, the vertex, this is a plus 1, so the vertex would be negative 1 because you are moving to the left. But 2, you write it as it is. So the vertex is negative 1 and 2. So if you have this form, you can immediately write the vertex. For example, if you write the parabola a times x minus h squared plus k, then the vertex would have coordinates h and k. The coordinates of the vertex would be h and k. So you take h with a negative sign, but k as it is. And the equation of the axis of symmetry would be always x equals h. Okay, here it's x equals 2, here it's x equals negative 1. This is the equation of the axis of symmetry. Notice that here a is positive, it opens upwards. Here a is negative, the parabola opens downwards. Now, how to find the x coordinate of the vertex, which is h, when we don't have this form, when the equation is written in this form? Well, let us see that in a minute. Look here. Now, what if we want to find the y-intercept? What is the y-intercept of this parabola? To find the y-intercept, we put x0, so the y-intercept is c. So 0, we have the point 0c. The point 0c is a point on the parabola. So here, 0c, this point is a point on the parabola. Now, since this is an axis of symmetry, so there is another point here. There is another point here that has y coordinates c. Well, here we have 0c. But what would be the x coordinate here? Okay, how can we find it? Well, we can find the intersection points between this line, y equals to c, and the parabola. So let us write ax squared plus bx plus c equals to c to find the intersection points. C cancels with c, and we have ax squared plus bx 0. If you take x as a common factor, we will have this equation, and using the zero product property, so either x is 0 or x is negative b over a. So 0c and negative b over ac. So the x coordinate of the other point on the parabola is negative b over a. Now, the axis of symmetry and the vertex lies there on the axis of symmetry is in the middle between these 2 points. So how to find the x coordinate of the vertex, which is h? You can add negative b over a plus 0 and divide by 2. Remember, if you have x1 here, x2 here, you want to find the number in the middle, you just add x1 plus x2 over 2. So negative b over a plus 0 is negative b over a. And when you divide negative b over a plus 2, this means negative b over a times half, or negative b over 2a. So what is h? H is negative b over 2a. So that's the method. If we have a quadratic function like this, the vertex would be negative b over 2a. This is h, the x coordinate, and k, the y coordinate, is f of this number. And k, f of this number, would be either the maximum or the minimum. If a is positive, the parabola opens upwards, and f of negative b over 2a would be the minimum value, of y, the smallest value of y, the minimum value of y. If a is less than 0, parabola opens downwards, and f of negative b over 2a would be the maximum value. Okay, the vertex is the maximum point, but k, the y coordinate of the vertex, is the maximum value in this case. And notice the equation of the axis of symmetry is x equals h, or x equals negative b over 2a. That's the equation of the axis of symmetry. Let us solve this example. Find the vertex and sketch the graph. Well, a is 2. B is negative 4. C is 4. H, the x coordinate of the vertex, is negative b over 2a. So negative 4 is 4. 2 times a, well, a is 2. 2 times 2 is 4. So h is 1. How to find k? K f of 1, which means you go to the function and you replace x by 1. So 2 times 1 square minus 4 times 1 plus 4. Well, 2 minus 4 plus 4 is just 2, because minus 4 plus 4 will be cancelled. So what is the vertex? The vertex has coordinates 1 and 2. And a is positive, 2 is greater than 0. A is positive. So this parabola opens upwards. So to sketch the graph of this parabola, we plot the vertex 1 and 2. This is the vertex, and then the parabola opens upwards. Well, we can find the y-intercept. What is the y-intercept? If you put x0, the y-intercept is 4. So 3 and 4. So this is the y-intercept. And this is the axis of symmetry. So this is 1, 0, 4. This is 1 unit. So if we go another unit to the right, the parabola will also pass by the point 2, 4. So we know 0, 4, and this distance is 1. So we go 1 unit. So 2, 4 would be the other point. And x equals to 1 is the equation of the axis of symmetry. So this is the graph of this parabola. Look to this exercise now application. This is the profit function given by this quadratic function. Find the number of units that give maximum profit and find the maximum profit. Well, since A is negative here, the parabola opens downwards. And we have the vertex in this case would be the maximum point, which is HK. And the maximum value of Y, which is the profit, because the profit here is Y, so the maximum profit would be just K. So to find the maximum profit or K, I need to find H, and H is negative B over 2A. Well, this is A and this is B. So negative B is negative 300 over 2 times A, so 2 times negative zero point 0.1. Use the calculator to find the answer. So 300 over zero point 0.2, negative with negative will cancel. The answer is 1500. What is this? Find the number of units that give maximum profit. Well, this is the number of units that will give maximum profit because this would be the h of this is the h, okay? So the x coordinate that would give uh, the y coordinate, which is k, is 1500. So 1500 units to get the maximum profit. Find the maximum profit. Well, maximum profit is just k, and k is f of h, and h is 1500. So it is not f, it is p here, okay, because the function is p. So we find p of 1500, negative zero point 0.1 times 1500 square plus 300 times 1500 minus 1200. So the maximum profit is 223,800 dollars. So this would be the maximum profit, and it occurs when 1,500 units are produced and sold. Zeros of quadratic functions. Well, how to find the zero? You put y equals to 0. So here, x, the value of x, is called 0 of the function. But to find the x-intercept, we also put y 0. So we mentioned before that the zeros are the x-intercepts. Okay, so the zeros are the x-intercepts. How to find the zeros? If you put y0, you solve, you have this equation. And this is the quadratic equation which we mentioned in the previous section. So we can solve and find the value of x using the quadratic formula given by this. Now, how to graph a quadratic function? We know that the graph is a parabola. If A is positive, parabola opens upwards. And in this case, the vertex would be the minimum point. If A is negative, parabola opens downwards. And in this case, the vertex would be the maximum point. Coordinates of the vertex, x or h, okay, is negative b over 2a, k or y is f of h or f of x. Axis of symmetry, x equals h or negative b over 2a. X-intercepts, if real, sometimes there are x-intercepts, sometimes parabolas have no x-intercepts. For example, this parabola, it has no x-intercepts, okay? So in this case, the solutions of the equation, of this equation, would be non-real, okay? If the solutions are real, then these would be the solutions, and these would be the x-intercepts or zeros. The y-intercept is easy. You put x0, and when you put x0, you see that the y-intercept is just c. If A is positive, this is the graph of the parabola. This is the axis of symmetry, okay, and the vertex is negative b over 2a and f of negative b over 2a. If a is negative, the parabola will open downwards and the vertex would be the maximum point. For this function, determine whether its vertex is a maximum point or a minimum point. Well, y equals negative x squared, if we write it in the form, plus 4x. So a is less than 0, negative 1. So the parabola opens downwards. So the vertex is maximum. Vertex is maximum point, okay, is the maximum point. And find the coordinates of this point. Okay, we need to find the coordinates of the vertex. So A is negative 1, B is 4, H would be the x coordinate of the vertex, negative B or negative 4 over 2 times negative 1. Negative 4 over negative 2 is 2. And now K, which is f of 2, so I replace x by 2. 4 times 2 is 8 minus 2 square is 4. So it's 4. So the vertex has coordinates 2 and 4. Find the zeros. Find the zeros of the function. All right. To find the zeros, we write 4x minus x squared. We put it equal to 0. And we solve this equation. Well, if you studied section 2.1, we can solve this equation by factoring. Take x as a common factor. Then 4 minus x would be 0. So either x is 0 or 4 minus x 0 or x equals 4. So these are the two zeros or the two x-intercepts. Find the y-intercept. Well, the y-intercept is, if you put x0, it is 0. So the y-intercept is 0. And sketch the graph. So let us sketch the graph of this parabola. It opens where? Downwards. The vertex 2, 4. 1, 2, 1, 2, 3, 4. So this is the vertex. This is the parabola, opens downwards. So this is the vertex 2, 4. What do I know? 0 and 4 are the x-intercepts. 3, 4. So 0 and 4 are the x-intercepts. All right. And it continues like this. So the y-intercept is also 0, the x-intercept is 0, so everything is fine. And the vertex here is the maximum point, which is 2 and 4. And the equation of the axis of symmetry, he did not ask, but the equation is x equals to 2. Name the graph of a quadratic function. Parabola. Okay, parabola. What is the x-coordinate of the vertex? Negative b over 2a. For this parabola, what is the x-coordinate of the vertex? Well, a is negative half, the coefficient of x squared. B is 12. So x is negative b, so negative 12 over 2 times a. Well, 2 times half is 1. 12 or negative 12 over negative 1 is just 12. So the x coordinate of the vertex is 12. What is the y coordinate of the vertex? It is y of 12. So we replace x by 12. So 12 times 12 minus half times 12 squared. So we find the answer. The answer is 72. So this is the y coordinate of the vertex, and the vertex would be 12 and 72. How can you tell whether the vertex is a maximum point or a minimum point? If a is less than 0, the parabola opens downwards and vertex is maximum point. If a is greater than 0, the parabola opens upwards and the vertex in this case is the minimum point. Is the vertex a maximum point or minimum point in 2B? Well, here A is negative. So uh, we have graph like this, and the vertex is the minimum point. So minimum. Since A is less than 0. The zeros of a function correspond to what feature? X-intercepts. The zeros are the x-intercepts. What is the y-intercept of this parabola? You put x0, you get c. So c is the y-intercept. This figure shows the graphs of two different quadratic functions, this one and this one. Use the figure to complete the following. Determine the vertex of each function. Okay. The vertex here, this is part A. Okay, this is the vertex. It's 3 and 16. Here the vertex is 3 and 1. All right. Determine the real solutions of f of 1 x equals 0 and f of 2x equals 0. So find the zeros of the function or the x-intercepts. Well, here, -1 and 7. Okay, 7 is the x-intercept, -1 is the x-intercept. Here, no x-intercepts, no zeros. All right. See, one of the graphs is the graph of y equals so, and the other is this one. Determine which is which and why. Well, here a is negative, so it should open downwards. So this graph is the graph of y equals 7 plus 6x minus x squared because it opens downwards. While the other graph, x squared is positive, so it is the graph of y equals x squared minus 6x plus 10. And determine which is which and why. Why? Because a is less than 0 here and a is greater than 0 here. So the parabola opens downwards and here the parabola opens upwards. This was the last question. I hope you uh, enjoyed listening to parabolas, quadratic functions.